I'm back, and now we want to talk about forces. So the concept of force is it's going to be a push or a pull. So when you push on a refrigerator, you are applying a force to it. Whenever you pull on a rope, and it's a tug of war, you are applying a force to it. When I take this thing and I let it go, that is a pull. So the earth is pulling on this thing as it falls. So that's an example of a pull. So forces cause pushes or pulls. And the person who came up with this idea was a guy by the name of Sir Isaac Newton. And we're going to abbreviate the concept of force. We're going to abbreviate it with the letter F. And then the official metric unit for force is going to be called the Newton, named after Sir Isaac Newton, and it's a capitalized N. So that's the official metric unit for any kind of force. So what do forces do? So they can do one of three things. They can change the speed of an object. So when a force acts on something, its speed changes. So like for example, the speed of this thing when it's in my hand is 0. And then as you can see, as it's falling, it's speeding up. It's going faster and faster. So another name for a changing speed is an acceleration. So therefore, forces cause things to accelerate. The second one is that forces can cause something to change its direction. So that if you've got a ball that's going in this direction and you got another ball that's going in this direction, so when they collide, they're going to exert forces on each other. And then, so after the collision, if they bounce off, then this one changes its direction and maybe it goes that way. And then this one, maybe it changes its direction and maybe it goes that way. So they change their direction as a result of forces. And then the third picture there shows that objects can change their shape. So if you take a tin can and you squeeze it, you're applying a force to it and you can change the shape of the tin can. Now, I do want you to know the names of the 4 fundamental forces and what do they do. Okay, so you should be able to tell me that on the exam. So that we're going to have gravity. Okay, gravity is responsible for holding the universe together. It holds galaxies together. It holds stars together. So objects that are very large, it's the realm of gravity that holds them together. Then you've got electromagnetism, which is what's holding your table together. It's what's holding your chair together. It's what's holding you together. So you got an atom, and then because of their electrical charges, they are held together to make a molecule, for example. Then you've got the 2 nuclear forces. So you're going to have the strong nuclear force that holds the nucleus together inside the atom. And then you also have the weak nuclear force, and what it can do is it can change a proton into a neutron, or it can change a neutron into a proton inside the nucleus. And so it's sometimes said that it's what causes radioactivity. There are other kinds of forces as well. So the one you're probably most familiar with is the force of friction. So if you take a box and you're trying to push it across a carpet, the 2 of them are rubbing against each other. So that causes a force of friction that slows down the box. And then there's other ones like centripetal force, and then there is also the Coriolis force. So other kinds of forces occur in nature. Okay, now let's do Newton's first law of motion. So he's got 3 laws of motion: the first law, the second law, the third law. So let's talk about Newton's first law of motion. Every object will stay at rest unless acted upon by an outside force. So if you have an object and you put it on the table, it's not moving, and it's going to continue not to move forever and ever and ever. Unless, okay, now if you push on it, did you see that it moved? So when you apply a force to an object, then it will do something. The second part says that if an object is in motion, it will continue to stay in motion at a constant speed forever and ever unless a force acts on it. So let's do that bowling ball thing. If you take a bowling ball and you roll it, you notice it tends to roll at a pretty much constant speed unless you put your hand out and you stop it, and then it stops rolling. So an object that is moving will tend to keep on moving with a constant speed forever and ever unless a force acts on it. And so here we got 2 pictures. One is pulling the tablecloth out from underneath the dishes. And how does that represent Newton's first law? Okay, if the dishes are standing still, they want to keep standing still even as you're pulling out the tablecloth out from underneath them. The second picture over there is showing some crash dummies. And those crash dummies are moving with a certain speed, but then the car crashes into something. And so those crash dummies will keep on moving unless they're buckled in. And so eventually they're going to come to a stop too. The question is, do you want it to be the seat belt that slows you down and stops you, or do you want it to be the dashboard or the windshield that you are going to go crashing into and possibly hurt yourself when that happens? So definitely know Newton's first law of motion for the exam. Okay, let's take a break, and when we come back, we'll talk about what happens in a moving frame of reference.